In this video, we want to evaluate the given integral and confirm the result. That is, check it by taking the derivative of your answer, and it should give you the integrand. It's got tangent square root of x over 1 plus tangent square root of x. We have an identity for 1 plus tangent square root of x. 1 plus tangent square root of x is the same thing as secant square root of x. And of course, secant square root of x is the same thing as 1 over cosine square root of x. So if we multiply the numerator and denominator by cosine squared, remember the tangent squared is sine squared over cosine squared. So if we multiply numerator and denominator by cosine squared, in the numerator, the cosine squared cancels with the tangent, leaves me with sine squared of x. The denominator, of course, the cosine squared cancels. So I'm left with this sine squared of x dx. And here are the identities we're going to be using. First one I've already used, 1 plus tangent squared theta is equal to secant squared theta. And then we have one for sine squared. Have a similar one for cosine squared. But here we have sine squared of the angle is 1 minus cosine 2 theta over 2. That makes it easier to evaluate than having to deal with cosine or sine squared. So I can replace the sine squared by 1 minus cosine 2 times the angle. In this case, the angle is x. So we have 1 minus cosine of 2x, and that's over 2. We have dx there. Let's just break this up this way. We have 1/2 integrated with respect to x. That'll just give us x over 2. I've got a minus here. The integral of cosine is sine of the angle. In this case, it's 2x. And then we divide by the derivative using the chain rule in reverse. Derivative of 2x is 2, so this comes over 2 this way. And then we still got this 1/2 out in front here. And we got plus the constant of integration. So the 1/2 here, and then the other 1/2, let's make this a 1/4 here. Just put a 4 here. And that is your answer for this one. X over 2 minus the sine of 2x over 4. Plus the constant of integration. Now to check it, we simply take the derivative of what we have here. And we have to get the integrand. I'll just do it over here. The derivative of x over 2 is 1/2. That's minus derivative of sine is cosine of the angle. I have the 4 down here. And chain rule, derivative of 2x is 2. Constant of integration, of course, has a derivative of 0. And this reduces down to 1/2 here. And now let's factor out a 1/2 out of this. Or we can rewrite it, instead of factoring out the 1/2, let's just rewrite it this way. It's 1 minus cosine of 2x over 2. And of course, that's just the identity for sine squared of the angle. In this case, it's x. So the ones, I had the identity right here. That's the one we used actually in this. So we're actually just reversing the steps. Sine squared of x is equal to 1 minus cosine 2x. So far we're here. And we want to get to this. So we need a tangent squared on top here. So let's just put this over 1 and divide this by cosine squared of x. And that's legal as long as you divide the denominator by cosine squared of x. So sine squared of x minus cosine squared of x, of course, gives me tangent. 1 over cosine squared, that's secant. Just using fundamental identities here. Secant squared of x. So what do we have so far? We have tangent squared of x over secant squared of x. But secant squared of x equals to, again, fundamental identity, 1 plus tangent squared of x. and that's your confirmation. Thanks for watching. We'll see you next time.